Good morning. It's 11:30. I'll kick off the session. Thank you for coming in today morning. My name is Vineet Tyagi. I'm the CTO for Impetus Technologies. Myself and Ajay Anand. Ajay is the VP of Marketing and Products at our partner Kairos Insights. So Impetus Technologies has been working with in helping several of our customers, enterprises, in their big data journey. Since 2010, we've helped demystify big data and then help productionize a lot of use cases for our customers. And what I'm going to share along with Ajay today is our experiences and our insights into, based on what we've seen, what are some of the challenges and drivers towards the data warehouse modernization? What are some of the challenges and some techniques in solving them, strategies in solving them? And then one particular area where, one of the challenges that in a modern data architecture comes up very frequently is that how do you have fast query access over very large data sets in Hadoop? And we're talking about billions and billions of rows, and do complex analytical querying on that. And that challenge would be talked about by my co-presenter Ajay, and he'll basically delve deeper and share some insights into challenges and strategies for solving that as well. So let's move forward. So what have we seen in our customers, and why are they really thinking of modernizing their warehouses? It's not that they don't work, they have been working, and they have been adequate in many ways. So these are some of the drivers that we've been seeing that are basically driving the data warehouse modernization within our customer base. So handling the big data and the 3 V's, or as the new definition is coming up, we also use the big data, the fast data, the new data paradigm. And handling that within the current data warehouse technology is not feasible. So that's a very big motivator and driver to bring in new data sources. And when the new data sources are being brought in, unstructured social data, the technologies just don't work. So you have to look for a newer kind of modernized tech stack to handle that. Silos are being broken down, so people are looking at advanced analytics where IT teams are being asked now to bring warehouse information contained and separated by line of businesses together to do much deeper insights. Other thing that IT teams are being challenged that's driving the new technology stack is the adoption is that they're being asked today to reduce the cost of infrastructure, be it ETL, be it the analytical processing that's happening, the mainframe processing, or any of the other infrastructural costs that there are. Now what's happening is IT teams on one hand have to do more, and the other hand they have to reduce cost. So that's an interesting phenomenon, and that's one of the biggest driver that we're seeing for the modernization push that's happening. And then interestingly, there are new data science paradigm which is emerging, and data scientists and analysts have been moving away and getting and are in some cases even demanding access now to samples. Earlier they were used to working with sample set of data. Now they're demanding that they work, the sample size is all the data. Right? So there is more interesting stuff that can happen. So applying science is another driver. And in a nutshell, the time to market, the earlier ETL paradigm, bringing data in, massaging it, data quality checks. So between the time when you had the data, relevant data, and between the time you had insights, enterprise cycles are anywhere between 15 to 45 to 60 to 90 days. And that's not working. That's too late in reacting to market, etc. So that is the biggest business driver that's driving the warehouse modernization. So in the last 7 years, as the Hadoop technology has evolved, what has been working for us, this is simplified. This is not the technically detailed version of the architecture. We can go into that level of detail. We have a lot of webinars that we do or whatever, but for this session, I just wanted to keep it at a very high level. So we've seen this blueprint being applied everywhere. On one hand, there is data ingestion, and newer types of data ingestion tactics are needed for streaming sources of data, unstructured sources of data, structured machine generated data, IoT, geospatial data, social data. All these newer types of data sources are things that you have to ingest. And as the ingestion is happening specifically in the streaming sources of data, your architecture, the modern data warehouse has to have some kind of real-time streaming application capability that you can make the judgment on the data as it comes in. So you don't make the judgment on the data once it's in the warehouse 20 days later, you're making the judgment right when you first touch the data. So there's the real-time streaming applications that can feed the data into the lake. The traditional data repositories are not getting out as yet. So for the next 5-10 years, it is going to be a logical data warehouse where Hadoop will coexist with the existing warehouses. So all of this beautifully coming together is the blueprint that we've seen that works. Now there are challenges in making this work, and the challenges are manifold, right? It is easy to set up a Hadoop cluster today. The distros have evolved tremendously. The cloud technology has evolved. It's relatively easy to spin up Hadoop clusters and start ingesting data. But what do you do with that data? Interestingly, I was at the Gartner BI Summit in March, where I was talking to a lot of the customers, Fortune 500 enterprises. Based on their feedback, Gartner had been doing some analysis, and they made a prediction that through 2018, 90% of modernized warehouses will be useless as they're overwhelmed with information assets captured for uncertain use cases. And that's something that we want to prevent, and our customers are worried about this. And how do you prevent this? The key to preventing this is visual data discovery. Now, what really is happening is the fact that you bring in a lot of data, you move data into the Hadoop cluster, and then you keep acquiring the data. Now, as the data sets grow larger, the teams, the IT teams and the business users lose the context. What is there? What is available? What can I do with these data sets? It becomes extremely hard to reach out and discover what's there and access the data. Right? So a common way to solve this problem that we have seen successfully is that basically you need to figure out a way to capture meta information about the data that is in the data lake and the data which might be outside of the data lake, and make that available to the user in a very easy to discover way. And what I really mean is that if you have certain aspects of your customer data, let's say maybe the transactions, the instant transactions that the customer might be doing in a Teradata or in a Netezza warehouse, and you have a deeper history of the last 7 years of transaction in Hadoop, you really need to see this and be able to discover what is where and how can I access it. So having this ability is critical, is really critical to make a modern data warehouse successful. And related to that is that you have to make the data in the lake smart. It is discoverable, but it has to be smart in the sense of that it's not dumb. And that's like, what kind of a definition is that? But to simplify that, what I'm trying to say is that you have to make the data smart in a way that it's easy to find. It has tagging, it has meta information, and there is no data that lacks all of this. Your coverage has to be 100%. It's not like half of your data sets conform to this standard and the other half don't, because then there is a problem of synchronization. Users know something that's there and some other data which is not there. So all of the data consistently has to be easy to find. It has to be easy to understand the context of what that data is, what a data set does, what it can do for you. And it should be easy to combine together, aggregate, and use in analysis. The other aspect of data movement that in the modern data warehouse we are looking at is we had to rethink the ETL plumbing. You know, the ETL pipelines used to bring in data from the system of records, and transformations used to happen, and they used to land that in ADW. Further transformations and data preparation could be happening inside the data warehouse, and then it's ready for consumption, doing the analysis or providing insights or dashboards, whatever it was supposed to do. Now, when you are going into the Hadoop driven data lake or a new data architecture, the challenge is that you cannot route the data through the ETL pipeline. And the reason for that is what we're increasingly seeing is the ETL pipelines have a lag. They have a lag, they introduce the lag of several weeks, and they do not support data democratization as well as exploratory data access. And what I mean by that is business users are exploring data sets, and you find something and you say, okay, if I add 2 more data fields about this customer, what would happen? Now, by the time you go back to your data, the IT team and say, hey, I want 2 more fields, it would be 6 weeks when you get back. You might have forgotten what it was. So you want an in-time exploratory access, right? So you have to look at how you would make data instantly as it originates available inside the data lake, such that it can encourage the research and the data science and other business users want to do. The other big challenge for modernization, the architecture we just saw and I presented a blueprint of, is the fact that once you have a lot of data and you have mastered the ingestion and you made it discoverable, it has to be ready for consumption, right? And the business users are increasingly wanting to have more control on how they visualize data. So there has to be an element of self-service BI that is being brought into, and that the modern data warehouse has to support, right? Without that, we've seen many customers, and we met with customers who have come to us and said, gee, I got all this data, I have 60 terabytes data sitting here, but my business users are just not using it. I've provided the HBase access, I have them in Hive, and I don't know why they're not using it. And the answer to that is because the business users don't know how to use it, right? They need a tool, they need something that is abstract and that is non-technical enough for them to make it easy for them to work with the data, right? So self-service over Hadoop is going to be one of the biggest challenge, and Ajay is going to talk about Kairos and some of the ways Kairos helps solve that and other challenges involved in much more detail. But what we're seeing is this is one of the I would say this, if you mastered the ingestion and the discovery part and you mastered this part, then you have a very successful implementation that of big data, a modern data architecture in your world, which is appreciated by business users as well. So IT and business coming together needs to have a self-service, an effective, easy to use self-service BI layer over Hadoop. What have we seen in the field in terms of how we actually go about implementing and enabling users with this modern data warehouse architecture has been that there's 3 broad areas of use cases we've seen. One is the pre-processing use cases using big data capabilities that are there in the Hadoop driven modern data architecture supplemented by the EDW. Use it like the landing zone. So if you recall in that blueprint, the first part was a landing zone. All the data that comes into the enterprise lands in one particular place. So Hadoop is proving to be a very capable landing zone. It's very cheap, easy to operate. You can land and do the ELT there, prepare the data, and then distribute it. And if it has to go into warehouses, existing warehouses, it can go there, or it can stay in the lake as well. The other category of use cases we are seeing is that has been working in the modernization is offloading. So what we've seen is that, and we're helping customers. Impetus does have an acceleration framework that we call the workload migration. It's pretty cool, one of its kind. Stop by at our booth and happy to give you a demo of that. But what it basically does, the offloading is, see, there are proven use cases implemented in Hadoop, in the enterprise data warehouse, right? Now, as the data moves into Hadoop, there is a lot of proven logic that has been created and written there, right? You could lift and shift some of those depending on what those are the best choices onto Hadoop. So we have a framework that allows for automated offloading of that. So the offloading kind of use cases are also another category of use cases that we are seeing the modern data warehouse and the architecture take advantage from. And then the other area is the exploratory, self-service driven use cases, where the big data capabilities, having access to all the data which was not available to you earlier together, gives business users, power users and IT teams ability to do something more with the data sets. So with that, I'll move on and invite Ajay to talk about some of the challenges and what you're seeing in the exploratory data world. Ajay, thank you.
Thanks, thanks, Vineet. So in the early days of Hadoop, there was a lot of excitement about bringing all the data into this common data lake. And the thought was that if you build it, they will come, right? So, once you have the data there, people will start using it. And that was true for, some of the data scientists and really technical users that could dive in there and start making sense of the data. But what people found was that for the business users, it really didn't go beyond a small handful of people utilizing the data in the data lake. And a lot of these projects would then stall because they couldn't then justify to their executive teams, the return on investment for building out the Hadoop infrastructure. So the barriers of adoption for the business user is really, the environment was too complex and it was slow, if you tried connecting your traditional BI tools, and the thought was, well, maybe I can connect, my tools like Tableau or MicroStrategy or Excel to, some of the query capabilities of Hadoop through Hive or Impala or something. But what they found as they tried to do that was that response time was really slow, because if you're trying to run a query on a huge amount of data, it's going to take minutes or tens of minutes sometimes to return because you're, just the physical aspect of running the query on a huge amount of data just takes time. So, there was a need for, building, making sense of this data and making it available to the business users so that, as Vineet mentioned, they could really take advantage of, self-service capabilities and really be able to interact and explore that data, right? So, here I'm going to talk about, our approach, and this is an approach that other people are providing as well. How do you create a layer on your data lake to make it simple for a business user to consume? So we call it the BI consumption layer. So a BI tool should be able to access the data, and for a business user, he should just be able to use this data from his existing tool without any learning curve, continuing to do the things that he's been doing, but now have the ability to really, take advantage of the scale and the granularity that's present in the data lake, right? So a lot of people, even today, because of the complexity, they decide that I want to explore, I want to have a report that shows this aspect of the data, and they go to a technical person, and the technical person, writes the jobs on Hadoop, and it comes back a couple of days later. But then you have a static report, right? So you've got a static report, and you get some insights from it, but it doesn't give the business user to then say, okay, now I want to follow a train of thought and see, why is something happening this way, right? And a lot of people, in the early days, even at Yahoo, when I started out in the Hadoop space, we would have data scientists and, who were writing algorithms on Hadoop, but when the time came to make it available to a business user, they would create aggregates and then move it into a database, an Oracle or SQL Server, and then have the business user run, Tableau or MicroStrategy or whatever to use that data. But you lose a lot trying to move data back and forth between the data lake and some database. One, the size of the data, and the other is if you're trying to minimize the size of the data with aggregates, then you lose a lot of the detail and the granularity of the data. So the question is, how do you preserve the granularity and the scale of the data and give your business user the ability to explore it and drill down to the lowest levels of granularity interactively. Okay, so that's what we set out. That's the problem we set out to solve. And the way we do it is, first of all, a typical scenario is, you're landing all your data, as Vineet suggested, into your data lake, and this can come from all kinds of different sources. The first thing people are looking to do is, how do I now start combining some of these data sets, start cleaning them, applying some logic to, maybe getting rid of, data that I don't need or is dirty, or transform it or write some formulas very simply without having to write any code, right? So this should be able to be done by a business user without having to do any programming, right? So the first step is, how do you transform that data with no coding at all, right? Once you've transformed the data, then you can define, the relationships between the different data sets, and you can say, okay, my customer ID in this data set is the same as my customer ID here. So even though it's coming from disparate sources, one could be social media, one could be your data warehouse, you can now link things together and say, okay, this is the same person that interacted with my customer support rep or, had a transaction, and get a holistic view of your data and provide the relationships between them. Okay. Once you've defined the relationships in your data, now you're kind of treating this as a real data warehouse in the sense of, giving, being able to define the elements you want to explore. What are the dimensions? What are the measures I'm really interested in exploring? And this doesn't need to be, just one set of dimensions and measures. This could vary by business user or by group. They can each take a look at, okay, I want to explore this set of data, and you can try it out. If that doesn't work, you can bring in some other additional data and then explore a different aspect of it. So the ability to define these dimensions and measures that you're interested in exploring, and then we organize them into multidimensional cubes, right? So the concept is has been around for a long time, multidimensional OLAP, right? But OLAP has never been available in this manner, in a distributed, scalable manner that runs directly on Hadoop, right? So that's what we provide, the ability to create those definitions, build those multidimensional structures, and run it directly on Hadoop so you get the full advantage of the scalability of the Hadoop platform. Once these multidimensional cubes have been built, now for a business user, they can connect to these cubes from Excel or Power Pivot or MicroStrategy or Tableau, or Spotfire, any of the business tools that they normally use, Cognos, business objects. And now it becomes transparent to them. So they just connect it just as they would with any other database that they use from these tools. And with the same interface that they're most comfortable with, they can now start exploring data regardless of the size. Right? So that's the capability that we're offering to the business user. So this makes it self-service, interactive for the business user. So now when they want to explore something, they don't have to wait for a technical person to go out and create the report for them. They can do it themselves, right? And this can be done by somebody, that's familiar with Excel or familiar with Tableau. It's as simple as that. So what this does now is you're taking, your data lake, which was maybe originally being used by a handful of people data scientists, technical users, and now you have the ability to really make it available to thousands of users in your enterprise, right? So this opens up, another can of worms, right? Okay, now all of this data I've collected, I'm going to make it available to all of these people. How do I make sure it's secure and scalable and accessible for all of these users, right? So the scalability, being able to provide concurrent access to these users, and hundreds of users at a time, being able to deal with the security of, just making sure that they only see the set of data that they're allowed to see, right? So how do you take care of, fine-grained access control, row level, column level access control? How do you make sure it's integrated with your security infrastructure in your environment, Active Directory, LDAP, Kerberos, single sign-on. How do you provide role-based access control? How do you provide integration with third-party encryption tools? So all of that needs to be accounted for as you are now expanding access to this data for all of your users in your enterprise. How do you make sure that a sales rep from this region is only looking at his data and doesn't have access to the other regions or whatever else he's not allowed to see, right? So that is, again, part of this BI consumption layer with the security aspect to it. So, let's take a look at a...
Quick question.
Sorry. Yep.
All of those providers on the top layer there,
Yep.
they offer tools and capability of creating that BI consumption layer already. What do you offer that these providers cannot do?
Well, so if our customers tell us that when they're trying to connect from Excel to their big data platform, things are really slow. Okay, our customers tell us that when they try to connect from Tableau themselves have told us that when users try to connect, directly from Tableau and try, to SQL queries on Hadoop, the response time can run in minutes to tens of minutes, right? So that is what we eliminate by building multidimensional cubes. Even in the traditional world, right? So you have databases, but there's a reason why things get organized into MOLAP or OLAP structures. Okay.
I understand that.
Right.
You have tokens up there as one example, which is perfectly capable of building those cubes.
Sorry, say that again. Who?
You have
Cognos, yeah. Right. Yeah. Right. So Cognos is capable of building the cubes, but typically those traditional tools build the cubes in memory. So you're restricted in terms of the size of the data that you're incorporating into the cube. Okay. With us, because we are doing it and storing it in a distributed manner on Hadoop, we can scale much beyond the capabilities of the traditional tools. Okay. So taking a look at a customer example. So this is an investment bank that was looking to do risk analysis across multiple asset classes. And this is something they had never really been able to do because of the size and scale of the data that they were dealing with. So they were getting silos of information, looking at risk in each particular silo, but they wanted to get a holistic view across all of their silos to kind of see what the overall exposure was for them. So the idea was to bring this data into Hadoop, and they first started off by saying, okay, we'll bring the data into HDFS, and then try connecting, using Hive or Impala, or move some of the data into SQL Server, SSAS, write some Spark jobs. So looking at different ways of being able to analyze the data. But for all of them, they were finding that it would take, the response times were slow, and it would take weeks to really get something done operationally and make it available to their business users, right? So they were looking for a solution that could interface provide an interface for their business users, whether they were using Excel or TIBCO Spotfire or, their own Java applications through their own portal, right? So that's, what we enabled them to do with the BI consumption layer that Kairos provided. So now they could have a single definition that could now be used by all of these different tools as well as their APIs, and get a consolidated view of their asset classes. So now, for the first time, they were able to take 20 days or even 80 days is what they're doing now. Previously, they could do 1 day at a time. Now they can take a look at 80 days across all their asset classes and get a holistic view of the exposure to risk. And then, the other thing they're interested in was, as new data comes in, and you've got, hundreds of millions of transactions happening every day, you've got a strict SLA in terms of incorporating that data into the cube, being able to get that data incorporated in the cube in a short period of time. So having the capability of doing that as well as new data came in. Yeah, go ahead.
Why didn't you mention tabular database? You only mentioned multidimensional cube. Why didn't you mention the tabular database? Is it in database?
A tabular interface versus the multidimensional?
Yeah, you mentioned multidimensional is cube. You didn't mention the tabular database. Is that on purpose?
Right. So, In terms of dealing with the data,
What's the question?
Tabular. Microsoft Tabular.
so, yeah, okay. So what she's asking about is a tabular interface versus a multidimensional interface. So with Microsoft SQL Server with SSAS, you can expose the data either in a multidimensional APIs, or you can flatten it out in a tabular representation. So the multidimensional APIs really give you a much more efficient way of exploring this kind of data as you're looking at different aspects of the data and doing slice and dice across it. Right? So that's what we chose to do. So it's exactly the same way as Microsoft does it with SSAS, but with the ability to scale much beyond what SSAS provides today. Okay, because we do it on Hadoop. So right now we cover, one part of it. Over the next quarter we'll provide support for Spark as well, so that they would have a consistent way of dealing with this consumption layer across all of their data sets and across all of their applications. So some of the evaluation criteria they used, when deciding on the solution. So the first was, really the first problem they were looking to address was, can it really deal with the scalability and granularity I'm looking for? And we see this from other customers as well. So this customer, they were dealing with 80 billion rows of data. Now we've got another customer that's trying to deal with a dimension with a cardinality of 700 million, right? And this is, for somebody coming from the traditional data warehouse world, those are mind-boggling numbers in terms of, dealing with a dimension with a cardinality of that size, right? And they were looking for response times in the seconds for not just warm queries, but also cold queries. How do you deal with, getting that fast response time for a cold query? Then it was, how do you make sure that your business user doesn't have to go through any learning curve? So if they're Spotfire users, they would continue to use Spotfire and connect to this data source. The next thing was, how simple is it, to take different data sets and transform them and combine them? Can it be done, without having expertise in the Hadoop platform, right? How can I make sure that as new data comes in, that it gets incorporated into this within a matter of minutes? Right? How do I deal with concurrent access? So we did, load tests with them where, for 100 simultaneous queries, right, which in the real world could represent thousands of users. If you think about, 100 queries going exactly at the same time on the data, and showing, that it didn't the response time did not degrade appreciably. And the final thing was, how do you make sure you have enterprise class security for, row level, column level access, or integration with their security environments. So those were some of the things that, most of our customers that we're talking to are looking at as they evaluate, putting this infrastructure in place. And then, for a lot of these customers, as they embark on the data warehouse migration journey, it really becomes important to be able to show the return on investment to the businesses that are investing in this architecture. Right. So there's a whole bunch of ways you can show the return on investment. Reduction in time to market. How quickly can you get results which were taking weeks before? You can do it in the matter of minutes or hours now, or the response time in seconds, right? The reduction in the development time, because now you're not really having to do any coding. All of this is done with visual tools, drag and drop interfaces. The productivity of business users, because they don't have to go through explaining what report they want and then going through another set of users who would now create the report and get back to them. Now they can do that directly themselves, self-service. Because you're keeping the data in Hadoop and you've eliminated the need to move it to another database or another data warehouse, you reduce the overall time and the operational costs involved. And then, really the biggest thing is the top line benefit of being able to do things that you were never able to do before. Get a holistic view of your data that you were never able to do before in your traditional data warehouse. So those are some of the drivers for moving to a modern data warehouse. Yeah, go ahead.
So how does Kairos Insights compare against the open source, like Keeling that you
Yeah.
made like open source right back in like 2014?
Right. So, we do get asked that question a lot. So last year, the product manager from Kylan was speaking at this conference, and he talked about the limitations and scalability. When you're dealing with large cardinality, they were talking about dealing with cardinality in the thousands or, hundreds of thousands. When you're trying to deal with 700 million cardinality, those tools, do not scale to that extent. We're working with a customer right now in the telco space that actually spent 9 months evaluating Kylin and could not, consolidate their data into the cubes with Kylin. And with us, we were able to turn that around in a couple of weeks.
What about Druid?
Yeah, so Druid, that's another, interesting approach, and you can do, roll-ups and so forth with Druid. First of all, there's a number of things that are missing in Druid. So they don't really, build the multidimensional cubes the way you do, and they don't expose it through APIs for the business tools to get transparent access to it. Okay, so it's still kind of a development interface, right? Any
Still
other
have
questions?
a few more minutes. If anybody has questions, we'll be happy to share our experiences.
Yep.
I was wondering, do you have any publications on how this impacts the cluster, the building of the cubes and all the frameworks that's needed before the users can use it?
Yeah, so we'd be happy to show you examples of that, how long it takes to build a cube. We've got data sets with, in fact, in the demo that we're showing right now, it's a star schema benchmark. We've got 100 billion rows of data, a 10 terabyte cube. We can show you how long it took to build that cube. And it's actually linearly scalable, right? So if you've got SLAs which needed to be done faster, you can use more, spin up more nodes to build the cube. But we can share those numbers with you and show you what it took. And over time, we're actually making that even more efficient as we move forward. And with support for Spark, that'll get even faster.
And another question on the installation, is it something similar to the yum installed and gets deployed on the cluster?
So we install it, the software is installed on an edge node and basically in a web browser, a web server. So you interact with it through a web browser. And that's how you define what the cubes are, and then it submits a job to the Hadoop cluster to build the cubes. And the querying processes are Yarn jobs that run in the Hadoop cluster. So there's nothing that needs to be installed or changed in your Hadoop cluster at all.
Yep.
Go ahead.
So can I just install the Hive ODBC to connect to the HTTP address?
So if you've got your data in Hive, we can read it directly from Hive. We don't go through ODBC to read Hive data. We just read the data directly through HCatalog, and the files themselves.
It's always better than use a Hive ODBC, is that right?
Yeah, so the response time that you would get with this would be much faster than trying to connect from a BI tool through ODBC to Hive. Great. So, we're going to be around if you have additional questions.
Thank you, folks.
Thanks.